Sorry.
Alright, okay.
Brown.
No.
Alright, law of cosines. Get your form. I should have told you this earlier. Get your formula sheet out, please.
Which one?
Your regular one. And write down law of cosines. Do you have the law of sines written down, by the way?
No.
Law of...
Do I? I don't know.
I have no idea. I haven't looked at your formula sheet.
What is that? What does that mean?
Alright, if you don't have the law of sines, make sure you have the law of sines written down. What's the law of sines? Anybody remember?
Oh, is it like?
A over sine of A equals B over sine of B equals C over sine of C.
Oh,
Yeah, I saw that.
yeah, I have that.
Easy to remember, but if you don't remember it, you better write it down. When we have a triangle that has straight lines instead of that, where do you want A? Where do you want side A?
On the bottom.
Bottom? Bottom left or right? Bottom left or bottom?
Bottom left.
Oh, alright, we'll do side A, and therefore angle A.
Oh, sorry.
Where do you want B?
Top right.
Okay, so side B, angle B, side C, angle C.
Are they doing this out of like, I want this there, or is this the right way?
Well, we always do, the way all mathematicians do this is we use the capital letters for the angles and lowercase letters for the sides, and you always have, you always do the side with the opposite, or the angle on its opposite side. So it doesn't matter where you put the A, as long as side A is opposite angle A,
Okay.
etc. And so here's the law of sines. The ratio of side A over the sine of angle A is the same as the length of side B over the sine of angle B, which is the same as the ratio of the length of side C over the sine of angle B. There's a lot of words there. In order to use this though, what do you have to have?
A calculator.
In addition to a calculator and a brain, what else do you have to have?
At least
At least three
Three.
terms. Yeah.
2.
Yeah, and there are 6 parts to the triangle. 3 sides, 3 angles, so 6 parts. You have to have, and in order to use this at all, you have to have at least a pair of corresponding sides. What if you knew side A, side B, and angle C? Can you use the law of sines?
No.
No. Unless it happens to be a right triangle, then you can do Pythagorean theorem with your sides, but otherwise you can't use the law of sines. When you're solving for missing parts of a triangle, you always want to use the law of sines if at all possible. Sometimes, however, it's not possible. And that's when your plan B, your backup gun, if you will, is the law of cosines. And in just a second, you'll see why this should be plan B, not plan A. For the law of cosines, here it is. A squared equals B squared plus C squared minus 2BC cosine A.
Fun.
Yes, it's very fun.
Why is that different?
Different.
Yeah. I have P squared equals A squared.
Move about an inch higher up on the
Sorry.
page.
Wait. No.
Now, there's different versions of it. If you look on your book, about a third of the way down, it actually has the law of cosines 3 times. All they're doing, the main point here,
Orange.
green, orange, and,
Blue.
what did you say, Red?
Right.
Sorry.
I said it louder and longer.
The main point here is that whatever side this is, you use it's that angle. And whatever side this is goes in these 2 spots. And whatever side this is goes in these 2 spots. You can switch up A, B, and C depending on what you need for your given triangle. So the next, so as long as these 2 correspond, this side this side and this side, you can switch them up as necessary. The other thing you can do, and horrible looking C.
In what scenario would law of cosines be easier?
It's not so much that it's ever easier. It just gives you a tool to use if you can't do law of sines.
There's a scenario where you can't do law of sines.
Yes, and that's why we have a whole lesson about it coming up in about 3 seconds. While you're writing this down, let's rearrange this equation. Sometimes this is useful. The other thing we could do is sometimes we want to know about the angle all by itself. So let's take this equation and solve for cosine A. So we're going to take the a squared that's already here, and we're going to subtract these two, minus b squared minus c squared, b and c, no, b and c, and I just realized we're going to be dividing by negative 2bc. Let me do this again. B, C, A. Alright, so b squared plus c squared minus a squared over 2bc. Did I do that right? Sorry.
You could have
Hopefully
messed it up
that's-
and you wouldn't tell.
What's that?
You could mess it up and you wouldn't know.
Well, that's encouraging. Okay. So these are the two main forms that you're going to want for the law of cosines. Please make sure you have both of them written down on your formula sheet. If you want to, you could write it down 6 times.
Why?
You did all 3 forms of this and all 3 forms of this. But if I were you, I would at least write these down. And you might be thinking to yourself, well, how do we get this? Can you give us an example?
Can we use this? Could you give us an example?
Absolutely, I'm glad you asked. Should we change colors? Purple.
Oh,
A color that's visible.
Let's move this. Alright, so law of cosines, lesson 81. Let's do example 81.1. We have a triangle. Actually, no, I don't really need that. Let's get rid of this. We can start a little higher. Example 81.1. We have a triangle. We have angle Y. Calls this one angle M. This angle is 36 degrees. We have 7, 10, and X. Now for starters, can I use the law of sines?
no.
Why? Yeah,
Because
no.
you don't have to
Let's just
compare.
say no.
No, I can't. Which means, bummer, let's use the law of cosines. We know the 36 degree angle. So let's see, we know the 36 degree angle. Let's use this one. If we only know the sides and we're looking for an angle, that's when this one is more useful. If we know what one of the angles is, let's go ahead and use it, and we'll plug it into this form right here. And just to make the point, we'll do it this way. I'm going to write down everything in brown here. Okay. Now what corresponds to my A's here? What angle am I using?
36 degrees.
36 degrees. So I'm going to use my angle of 36 degrees, and the corresponding side is going to be X. Alright, now, let's see, what do you want to do for B? Which one should we call B?
7.
Okay, we'll call this one B, and that's going to go here, and here. And then our other side, we'll call this C, and this one's going to go here and here. And now we get to about our electronic brain. Plug all this in,
plus or minus?
We are looking for the length of a side of the
Oh,
triangle.
yeah, never mind.
So I hope you don't get a negative. All right, Caleb, what do you got?
5.978095508.
Okay. And Tanner, what do you get?
5.97829.
What was yours again, Caleb?
80.
What?
Mine.
So a smidge off, but we're talking about what? Tenths, hundredths, thousandths, 10,000ths. I'm not worried about being 2,000ths. No, 2/10,000ths off. Okay. Who else is done?
I'm done.
All right.
5.9781.
Don't even.
5.9781. Okay.
Probably the most exact.
Is
Don't
it
even
done?
ask me that. I don't know.
Okay.
It didn't work.
Okay. What you get?
No, I don't want to say.
Welcome to
You know,
the club.
to be honest, I was actually kind of hoping that we would get several different answers. All right.
Well, you did. We just won't tell
All right.
you
So
what
the two people with the
answer is.
inspires did fine. So the rest of you
I'm
that
at
have
35.7 twice.
take the square root of that
It's X
Why did I
squared.
take the square root of that?
It's X squared.
because it's x squared.
Why is it not plus or minus?
Yeah, that's what.
Oh, well, it has to be plus because it's a measurement.
Because we're talking about the length of a side of a
Okay,
triangle.
yeah, I know, but I.
Unless you know how to draw me a triangle that has one side has a length of negative 5.98, which would probably revolutionize something or other, I'm sure.
5.970.
There we go. We're right in the same ballpark.
You use an imaginary triangle.
I was
Sure.
so mad at myself. I was like,
Or flip, so it was like.
If you want to do so, if you well so here's the thing. If your calculator skills are good enough that you can write this down, do it, and get the right answer, fine. But it's probably a good idea to show your steps, at least somewhat. 7 squared is 49, 10 squared is 100, minus
140 plus
140 times, what's the cosine of 36?
Don't know.
That would be 0.809. It would be a good idea to show at least a few steps. So if I multiply that by 140, that's going to be negative, plus 149 is going to give me 35.738.
What's cosine 36?
0.809.
Are you in radians?
In that case, you might be in radians.
Luke,
Well,
Oh, that's right. That's what happens when you borrow a calculus student's calculator. They're most likely to have their
yeah, it's
calculus set to radians. Which means that when she gives you your calculator back, you better change it back. So the square root of both sides. Now, in general, anytime you do square root of both sides, you do plus or minus on the right. In this context, we are looking for the length of a side of a triangle. It's not going to be minus. So square root of that is where we get our value of 5.98-ish. That's a 5. Well, that was pretty exciting. Let's try, so now we know side x. Let's solve for y and m. Now, we could, if we really wanted to, and we were gluttons for punishment, so to speak, we could we could use the law of cosines again and solve for some of the other parts. However, now that we solved for this side, we now have a corresponding pair of side and angle. So at this point, we may as well use the law of sines. For the rest of it, it'll be a whole lot easier. So what's our ratio going to be? We've got 5.98 over the sine of 36 degrees is going to equal, what did we decide here? The green one was going to be B, so that's going to be 7 over the sine of M, and that's going to equal 10 over the sine of Y. Actually, let me write it this way. I'm going to put this one in the middle.
just multiply it out.
And the reason anybody know why I did this? Why I did it that way? Anybody want to guess? If I cover this up, there's a proportion I can use to solve for y. If I cover .6 equals 5.98 times the sine of n.
36.
What am I gonna do? You have a calculator, ready, go.
4.11 is the sine of 7 times 6.
688.
And then you gotta multiply 5.9 whatever times sine.
No.
Wait, and then you just divide it, right?
Divide this by 5.98.
You gotta, oh,
Okay.
0.6.
Actually, I can do that here.
0.6, I think. Why not?
Romaine guy.
Alright, so at this point I've got 0.688 equals sine of m. Now what?
Inverse.
I'm looking for the angle, so I need to do the inverse sine. Show it to you like this. I have a big little space here. And I've got sine of m equals 4.11. This isn't technically the math way to do it, but sometimes it helps my brain to think of doing this. So I've got just m on the right, and so the inverse sine of 4.11.
You didn't divide it.
it's not
Oh, that's
fine.
right. Oops.
0.688.
Thank you. There we go, that looks better.
43.
Inverse sine, and m is going to be 43.49 degrees. If you didn't get that, please get some help so we can, I want to make sure that you know how to do this. If you've already gotten that one, let's do the same thing with y.
Or we could just take 43.49 plus 36.
That's true. Why don't we do that?
Well, you doesn't have to add up to 180.
Yeah.
That's exactly. I'd forgotten about that, and that's what Caleb was just reminding us. That in a triangle, all three angles need to add up to what? 180.
360.
So if we do, so we have our angle. Ooh. So if we have 36 degrees, the m is 43.49. And we don't know what y is. All that needs to add up to 180 degrees because that's what there is a triangle. And yes, good call, because just like the law of cosines versus the law of sines, if you can use the simpler method, it's usually a good idea to do that. And by the time we have two angles, the simplest thing to do is just say that all three angles need to add up to 180. And so what do we have for y?
5.83.
I get a y of 100.51 degrees. Because I did not round anywhere. Just because I wrote a rounded number doesn't mean I didn't round it on my calculator. And there we go. So now we have found the missing parts of the triangle.
Yay.
What haven't I used yet? In this one,
Black.
blue.
Black.
Brown.
So I found what was missing. I was missing y, m, and x. I found x, I found m, and I found y. And so there's the three answers to my question.
I think this
Now.
was the most my class would include.
Quite possibly. So we've done all this for one problem. Now it is your turn. We don't need to have this on video. Thank you very much.